Yeah, so hi guys, and hope everyone is doing well and staying safe. And I warmly welcome you all to the third episode of the AWS webinar series done by the T and Tech Innovative in collaboration with the AWS Focus Group at 99X. So if you're into AWS serverless computing and like want to be a hero from zero, this webinar series will help you in a massive way. So if you all have missed out on the last few sessions, you all can go on to our YouTube channel and check it out there as well. So this webinar series contains of 4 sessions, and the topics that we have covered so far are the introduction to serverless computing and AWS compute services. And today we'll be talking about AWS Datastore services, and then the upcoming session will be on application integration services. So these sessions, come with practical demos where you can do hands-on sessions with the speaker, and like if you're stuck at anything, you can go ahead and ask the speaker as well. So in today's session, you will get to know what exactly AWS Datastore services are and how we can utilize it. This webinar will also explore the basics of AWS Datastore services and look at some use cases in depth as well. So thank you once again for joining us for this session. And yeah. So thank you again for joining for this session. And like if you have any questions, we'll be answering them on the Q&A session at the end. So as the speaker for today, we have Keshav Kumarasan, who's an associate tech lead with more than 4 years of experience as a developer, and who is also an active AWS community builder, and he is also a co-organizer of the AWS user group Columbia. So Keshav also involves himself in all stages of software product development with significant exposure in AWS services. So without wasting much of time, I warmly welcome Keshav to take over the screen and go ahead with the session.
Yeah, thank you, Ishrat. Thank you for that welcome. And yeah, let's get started with the session then. Thank you. Good evening, guys. So my name is Keshav, and today we are going to talk about serverless data store services on AWS. So if you just look at the brief agenda, first I will just talk a little bit brief on what are data stores and what are the differences between the storage services and databases in AWS, just to clear out some of the terminologies I'm sure most of you guys will already know. But since it's a kind of a beginner-friendly session, I wanted to cover all the terms first before we dive deep into it. So first I will just go through that, and then I will go through some of the commonly used AWS storage services and then some commonly used AWS databases. And we'll also do a quick demo just to go through how we can get started with some of these services and how easy it is to create your own database and things like that. And we'll also briefly discuss about the pricing as we go through each of these services. So if we just briefly just look into the definitions here, most of these slides I put up the definitions, but I'm not just going to repeat it because there's no point. So I'll just be talking, but the definitions will be usually up on the slide. So why I wanted to add this slide is I'm going to talk about storage services, and I'm then going to talk about databases. If there's some confusion there, the only difference there is now data store means it's kind of an umbrella term. That means any storage solution that allows you to store any type of data, whether it's documents, images, CSV files, PDFs, any kind of data, then it's called a data store. But a database, on the other hand, will be usually managed by some sort of a database management system. Whether it's NoSQL or SQL, it's generally using a DBMS. So the main use case here is that the main difference here is that the data in the databases are usually typically presented in kind of tables and collections. There will be relationships, and you can properly query the data. You can index the data. Maybe generic data stores might not provide that kind of a functionality, but databases are more specific in that case. So a database can be considered a data store, but not all data store are databases. I just wanted to clear that because first we are going to talk about normal storage services, and then we'll talk more about databases. So yeah, so if we start looking at the storage services in AWS, there are multiple solutions. Apart from these also, there are some more as well. I didn't want to go through all of them because they're not technically serverless or not very relevant. But these are some of the most commonly and most famously used storage services, out of which the first thing S3 is fully serverless as well. Then we'll talk about EBS, EFS, and the other things mentioned here as well. But yeah, so if we first get started with S3, S3 is one of the most commonly used service in AWS. It has been there. It is one of the service that was introduced at the beginning of AWS as well. So what it does is basically you can store any type of, it's kind of a object storage. So you can store any type of an object. It can be a image file, it can be a PDF, it can be a Word doc, it can be any kind of a document. So you can store that document very reliably, and it can scale up to a petabyte scale. So you can store massive, very large amount of data as well, and S3 can take care of it. So mind you, it's a storage service. That means there's no kind of a tables or anything like that. But they do have something called buckets, where you can store different, you can create different buckets, and inside each bucket, it's kind of like a logical encapsulation. So you can store different types of data inside a bucket. There's no restriction as to what type you can store. Pretty much all types of data you can store in a S3 bucket. So some use cases would be if you are trying to host a static website, or if your application has some image upload or document upload service. So if you want to store those photos or images in a secure location, then you can use an S3 bucket. Or if you're an application like Netflix, where you want to provide content to your customers, provide secure content to your customers, where only certain customers who have purchased your application can view certain data. Those kind of complex scenarios can also be achieved with S3. So any kind of content sharing or content saving and retrieving you can do using S3, and it's one of the few services that provides this 11 nines durability. So that's 99.999. So 9 more nines there. So what that means is it's very rare for it to go down. So any data you store there will be, it's pretty much 100%, it's very close to 100%. So it's going to be highly available. So that means at no point in time will it go down, or you might not be able to access or download the data you put into S3. So it's going to be very durable, and AWS is guaranteeing that if they don't, if certain incidents happens, and if it doesn't comply to this 99%, then you can actually sue AWS, saying you guaranteed that percentage. So they are pretty confident about that, and it's pretty durable that way. So that's mainly S3, where the main usage of S3 is to store different types of objects, and you can use it for different applications within AWS and outside AWS as well. I will show that later in the demo as well. But another thing I want to just briefly talk about S3, because generally when you talk about S3, these terms come up as well. And if you are doing some sort of an exam also, these terms come up as well. So I just wanted to briefly tell them as well, because S3 has a certain concept called storage classes, meaning the data you store there can be tiered into different options, so that based on how frequently you access it or how frequently you update it, you can customize like how much you want to spend on it. If you're storing data that you want to rarely access, and you just want to archive it or something, then you don't have to pay so much. So S3 gives you that option to choose what kind of data you want to store and how long you want to store it, and customize how much you want to pay as well, because then you don't have to pay so much as well. So for example, here the standard tier is how you generally, when you normally upload an object to an S3 bucket, it goes in the standard tier. But then there's this infrequent access, where if you have rarely accessed data, let's say if you're uploading certain images that you don't access for more than 30 days, then you can put it in infrequent access, then you'll be charged less for that. Similarly, if it's more than 30 days, if you're going to store it for 100 days or years on end, then you can use this thing called Glacier, where it will allow you to archive the data. So any kind of archival processes you can do using Glacier. And even in Glacier, there's 3 different options where you can, if you want it immediately accessible, or if you can wait a few hours to access it, then you can go between this instant retrieval and then deep archive as well, which basically means you can, if you want to immediately download a object, then you can say, okay, keep that object a little hot. I will pay a little bit more, but keep it a little hot so that I can immediately download it. Or you can say, even if I want it, I don't really need it immediately. I can wait a few hours. It's not very mission critical for me. So those kind of data, even it'll be very cheap, like $0.005 or something like that per month or something. So it will be very cheap for you to store that data in deep archive Glacier. So, and finally there's this thing called intelligent tiering, where it'll automatically, if you are not sure how long your data is going to be stored, and if you're not sure, now for these kind of tiering, you need to kind of have a knowledge of how long your data is going to be, how frequently you're going to access, or how long you're going to keep it in the bucket. But if you're not sure about that, you can turn on that intelligent tiering, where it'll automatically it'll kind of analyze how frequently you're accessing it, how frequently you're updating it. And based on that, it'll automatically assign a tier for it, and it'll try to reduce the cost for you. So you don't have to worry. So that's the main thing about S3, is that it's fully serverless, and even cost-wise also, it's trying to automate that, so that you don't have to, the amount you're spending also will always be the lowest amount you can possibly spend, so it's making sure of that. And this is just these are just some images I took from the official documentation, just to give an overview. But you can see here, S3 can be used to store these any kind of data, whether it's videos, pictures, or whether it's log files or it's application data. You can store it in S3, and then from S3 you can pull it out to different other services as well, whether it's within AWS or whether it's other third-party services you want. You can use it for analytics, you can use it for your application, it's up to you. But the data stored in S3 is reliable, it's secure, and you have a lot of control over how you can manage it as well. And this is another nice infographic I found. There's this website called awsgeeks.com. I'll show that in the end, but it's a good website where you can learn quickly about different services, especially if you're learning for a exam or something. This is useful for a certification. So I just added these for all the services I'm talking about today. But so here I just wanted to highlight, here they're talking about the storage class transitions, and you can encrypt the data, and then how the data can be transferred. And they're also talking about the pricing as well. So different tiers have different levels of pricing, as you can see here. And although it's pretty low, it gets even lower if you go to different tiers of storage. So, and here they're talking about the availability and how the durability works as well. So if these things goes down, how it's going to be recovered in case if anything goes down. So there's always that guaranteeness of availability. I will provide the link for these later, so you can leisurely go through them, but I just wanted to show them because it's a nice little thing to quickly get an idea about particular service, or to just refresh your mind, So that was S3. S3 is a very good example of a serverless offering of a storage service in Amazon. The next few things are not technically serverless, I would say, but they are often used with other serverless services, and they are often used in a lot of different workloads in AWS, and they're very popular. So I thought I'll add them as well. So I'll quickly go through them as well. So the next thing is called EBS. It's called Elastic Block Store. So this is something which we kind of showed in the previous session as well, where we were trying to spin up an EC2 instance. So EC2 is used for compute in the cloud, and for any kind of compute service, you would require some sort of a network storage as well. So that is what this Elastic Block Store provides, where you can store data for a particular compute virtual machine, let's say. So for a particular virtual machine, it will require some sort of a disk storage, right? So that disk storage can be provided using this Elastic Block Store. So in this also there's options like you can use hard disk, HDD or SSD, and even in an SSD there's very high throughput optimized SSDs as well. So depending on your workload, you can choose what type of a volume you want, and you can attach that to a particular EC2 instance. That might be a little bit technical, but what it basically means is usually even in a normal PC, we have these local disk storage where we have different partitions, local disk D, local disk C, right? So similarly, in a network, in a virtual machine also, that also will require storage for it to boot up the operating system and stuff. So that storage is basically provided by this Elastic Block Store service. It generally comes along with the EC2 service, but I wanted to mention it here because it's very highly used in the AWS ecosystem. So it's good to know about when we are talking about storage services in general. So the volumes that are offered are very consistent. It's very high performant and low latency. And it can also scale up and scale down within minutes. So that's why I said it's even there are servers here, as in certain amount of because since it's a storage service and the disks are up to you, you have to do a little bit of management there. But then again, it's also going to do a lot of the things automatically as well. For example, the scaling up and the security and the encryption and things like that. So it is taking a lot of workload out of you as well. So if you look at another summary here, EBS is, as I told, it can be SSD based or HDD based. Where you would choose them is based on your workload again. If you want really high disk optimized workloads, for example, if you're doing some high intensive machine learning algorithm or something, then you might go for an SSD based block store. But if you're doing very slow processing that doesn't really require a lot of disk, then you might choose HDD based storage. So based on what you choose, the pricing will also differ. The HDDs are a little cheaper than SSDs, but generally you will choose one of these and you will attach it to an EC2 instance, and that instance will start to use that particular volume. So one thing to note here is that generally an EC2 instance or a compute or a virtual machine will be connected to only one of these volumes, EBS volumes. There is a certain scenario here where you can attach multiple instances to a particular same volume as well using this AWS Datastore thing. But that's kind of an inconvenience. It's not available for all types of instances. It's only for that AWS Datastore enabled instance, which is another topic altogether. I don't want to go too deep into it, but it just means that you can't easily attach multiple instances to one volume, one EBS volume. So for example, even in your local hard disk, you can't directly connect that to a different computer, right? It's connected to the same machine. So same concept where one instance is generally connected to one storage. But there might be, especially in a network or in a cloud situation, you might want to use something shared, but you still want that kind of a low latency performance so that you can immediately access the data. So in those kind of scenarios, only the next service I'm going to talk about will be useful. It's called EFS. So EBS is used for only one instance that is connected to one storage, but that storage will give proper performance for that particular instance. But if you want to share that storage across multiple instances, let's say sometimes we have these network drives in our PC or in our intranet where we can connect to a common storage like an FTP server, something like that. Here it's called, here it uses a different protocol called NFS, Network File System, and it's used for Linux machines. So where different EC2 instances or different virtual machines can all connect to the same storage solution, and they can all parallelly communicate with it. They can all parallelly read and parallelly write, and it can provide full maximum throughput with low latency for all of those instances. So an example scenario there would be like if you're doing a massive machine learning workload or a big data workload where you're trying to break the data down and you're doing processes individually in different virtual machines. Then you might want to have a shared storage to read the data from and write it back to, but it also has to be very low throughput, and it has to also allow parallel connections to it. So in those kind of scenarios, this EFS, Elastic File System, is very useful. So some other use cases here are lift and shift big data, web serving, content management, application development, database backups, etc. So it's useful when you want to, when different instances want to share the same data. But it doesn't necessarily have to be instances. It can even be these AWS Lambda functions, EKS or ECS, AWS Fargate. So these are all other serverless services. I think some of them were discussed in the last session as well. So most of these compute services, they can all read and write into this EFS file storage. So it's pretty useful when you are doing massively concurrent workloads, and they all want to share the same data. So that's what's shown in this flow as well. Here they are kind of moving the data from their on-premise server into the EFS first, the file storage first, and then the AWS, the cloud services are kind of using that data. But that's just one flow. You can use it in different ways you like it, So this is another infographic on EFS. So one thing I wanted to highlight here is EFS also has something like a lifecycle or like a storage tier compared to what we saw in S3. Here also you have an infrequent access, where if you think the data stored there is not going to be accessed for 30 days, then you can move it to that infrequent access. Then you can save around 85% on storage costs. So it's a nice option if you have something infrequently accessed. Similarly, another thing I wanted to highlight here is you can also do, you can protect it with a virtual private cloud, which is another concept, which is basically you have kind of a private network within the AWS infrastructure. So you can keep that EFS also inside the network, so it's secure, and you can encrypt it as well. So even if the data is read, it doesn't make any sense. The pricing here is again, it's on demand, so you pay for only what you use. There's no subscription or anything like that. And the payment will also change based on how long you're accessing and how frequently you're accessing the data as well. So yeah, finally, when we look at the three services we just discussed, the EBS, EFS, and S3. So S3 is an object storage. EBS, Elastic Block Store, is a block storage, and EFS is a file storage. That's the main difference if you look at it terminology wise. Use case wise, S3 is used for generic use cases where you just want to do store the files and retrieve it, not for virtual machines per se, but for anything, for applications or for website hosting, anything, then you can use S3. But EBS and EFS are mostly for compute related stuff, for virtual machines and other kind of compute services to use the storage for their own application logic. Then you would go for EFS or EBS. So in the next slide also, I'm going a little bit more deep on how. So if you want to choose the correct option here, S3 is correct when you want to choose, when you want to store objects, as I told, like if you just want to do simple object storage and retrieval, either manually or programmatically, then S3 is the best choice. And the Glacier is good for archiving objects. Meanwhile, EBS is good for, it's an expert storage for one EC2 instance at a time. So it's only one compute or one virtual machine will connect to one storage. And EFS is good for when you want to share that storage across multiple instances. It's a network file system. That's a protocol used by these Linux instances. And it uses this protocol called POSIX file system. It's like NTFS and FAT32. This one is called POSIX. It's a different type of file system. So it has to use that protocol when it communicates, but it's pretty high performance. Yeah, other than that, there were some other services that I mentioned here in the storage service, but I didn't quite talk about that. Those are called the storage gateway, transfer family, and data sync. And then the Snowcon, Snowball, Snowmobile, and FSX. So why I added these here is they are not technically serverless, or they are not very highly used. At least a person who's starting off in cloud wouldn't generally use that. But they are very highly used if you're trying to move your data from your old on-premise servers into the cloud. Then you need these things. They are mandatory for those. I just wanted to add them here because since we're talking about storage services, I have to mention them. But so for this FSX here that I mentioned here, it's similar to EFS. But it's for Windows systems. So the EFS I mentioned is only for Linux-based systems. FSX for Windows will allow to do the same thing where you can mount the same storage into different Windows virtual machines, and all of them can access the same storage. So then you can use FSX. Then you have the storage gateway, transfer family, and data sync. They all do pretty much the same thing, but in different ways. It's just that they are going to help you to move your data from either from your on-premise server to cloud, or from one cloud account, let's say from one AWS account to another AWS account. So it helps to move data, massive amounts of data, using standard protocols. So the the transfer family will allow you to use FTP, SMTP, those kind of transfer protocols to transfer data. And then data sync will do like automated data syncing between your on-premise server and your cloud database. And then finally, the Snowcone, Snowball, and Snowmobile, they are kind of a unique service, because what they'll do is AWS will send a device to you. Physically, they'll send like a box to you. If it's Snowcone or Snowball, they'll send like a box. And then in that box, you can load the data, your your application data or your on-premise data. You can just copy it into that machine. It's like a massive portable hard disk. They'll send a huge box. So you can load the data into that and send it back to AWS, and they will take it and load it into their own servers. I don't think it works here in Sri Lanka, but it's there in America and more mainly in America, I think. And the final one there, the Snowmobile, they'll send a massive truck to your house. Like it's a huge truck which can hold up to petabytes of data. So they'll send that truck and you can load the data into the truck, and then it'll go back to AWS headquarters and they'll load the data. So as I said, the last two things are mainly for moving data from on-premise to cloud or from cloud to cloud. But the first three things are only commonly used in AWS services for storing different types of objects or files or blocks, and mainly S3 is the most commonly used serverless offering, and it's pretty powerful and durable as well. So those are the main services I want to go through in storage. So after this, I wanted to talk a little bit about databases. So in databases, we have there are several different database services in AWS. We have RDS, Aurora, Dynamodb, Documentdb, Neptune, so on and so forth. But so most of these are serverless. Some of them have servers that you kind of sort of have to manage. But so I will go through some of the main serverless offerings here in AWS databases. And the first thing there is called the Amazon Aurora Serverless. So to talk a little bit about the Aurora Serverless. Now, Aurora works under something called this RDS, which is called the Relational Database Service. Under that service, you can pretty much spin up any type of database you want, whether it's MySQL, PostgreSQL, Microsoft Office SQL, Microsoft SQL, and Oracle, and yeah, pretty much. I think that's it. So those kind of SQL type databases you can spin up using RDS. So under that, Amazon provides something called Aurora. So that's kind of their own proprietary service service that they have developed. And what they are guaranteeing is that Aurora will do, it's much more performant. It's 5 times faster than normal MySQL databases and 3 times faster than normal PostgreSQL databases. So they're guaranteeing that it's much faster. And in this Aurora database, there's a serverless offering. So what that means is Generally, when you start to try to spin up a RDS, I will show this in the demo as well. When you try to spin up a general relational database, you would have to mention how much disk I want, how much CPU memory, and how much storage I want. You will have to mention all of that, and then that will spin up an actual EBS. It'll spin up a volume so that you can then use that as the database. But the problem there is it's still kind of not fully serverless because you still kind of have to manage that particular instance that it's spinning up. That's how it will work if you're generally trying to spin up a RDS database or normal Aurora database. But if you go for Aurora serverless, what that'll do is it'll maintain that entire server thing automatically. Meaning you don't have to tell how much CPU and memory I want. You can just give it a rough value, and based on that, it'll spin it up. And if certain load, if there's too many queries to your database, or if you know there's going to be a lot of users coming into your database, then you can allow it to automatically scale up and scale down. So if there's a lot of users coming in, the database will automatically scale up so that it can easily accommodate a lot of requests parallelly coming in, and when the load goes down, it'll automatically scale down as well. So that thing is useful in this Aurora serverless offering, where it's going to allow your MySQL and PostgreSQL database to be managed serverlessly so that it'll automatically scale up and scale down quite fast. So it's pretty easy to do as well. I'll show that in the demo. And you only pay per second basis. So you don't, you only pay for what you use. You don't pay for it's not a subscription based thing anyways. So that's also pretty useful. It's a useful feature when it comes to AWS, especially Aurora. So if you look at the graphic here, the Aurora is, as I said, it's MySQL and PostgreSQL compatible. And it kind of directly integrates with other services as well. For example, the SageMaker, Lambda, EKs, and stuff. So what that means is other services in AWS can directly talk with these relational databases, and they can either do some processing and write back into it, or they can, they can directly access the database without much problems. So Aurora is pretty fast, and the server there is also managed for you, and it easily integrates with other services as well. So it's pretty good option if you want to spin up a new MySQL, or even if you want to migrate your existing one into the cloud. And if you think your instance is going to be heavily used by other services in AWS as well, then Aurora serverless is a no-brainer, because it's going to manage everything for you, scale up and scale down for you as well. So that's also showed nicely in this infographic, where you can tell what kind of when it hits like 70% CPU utilization, then scale up, or when there's 90% connection utilization, then scale up. So you can set those kind of variables on when you want it to scale up and scale down as well. But and when it scales up and scales down, it'll have kind of a break, like a cooldown period as well. So it'll gracefully handle it so that there's no jerks, or there's nothing suddenly the availability doesn't get affected, is what I'm trying to say. So they make sure the database is up and running. And also you can have a cluster of databases running as well. So it will automatically maintain the balance, the load balance between the cluster, as well as it will keep the clusters consistent as well. So it will keep it replicated and consistent as well. So Aurora serverless is a pretty good option when you want to go for a serverless offering of a relational database in Amazon. As you can see here, they use something called this Aurora capacity unit, which basically means how much CPU and how much RAM you want to allocate here. It doesn't mean you're actually spinning up a server here. You're just telling, I just want this much of RAM on general. But if something happens, it will automatically scale this up and scale down as well. So it has that capacity to do that. So that's the first offering I wanted to talk about. It's fully serverless. So that's why I wanted to mention Aurora serverless. But so that's the one relational database here. pretty much everything else is no SQL, so it's non-relational. So the next thing is DynamoDB. So DynamoDB is NoSQL, and it provides a key value or a document database where you can store JSON documents. So I think you guys are familiar with key value or JSON documents, where it's just you mention a key and then there's a value right next to it corresponding to it. So the thing about NoSQL, or the thing about key value stores, is that the structure is pretty dynamic there. One document can have different keys compared to another document. It doesn't have to be consistent across the board. And that's the main reason why you would go for a NoSQL solution anyways, is because certain modern applications have data that is generally evolving rapidly, so it will keep on changing, and it's very dynamic these days. So in a situation like that, DynamoDB is a good offering because it can handle more than 10 trillion requests, and it supports 20 million requests per second. So it's very highly scalable, and for situations where you want to store this kind of dynamic data and you want to query it very fast, then DynamoDB is the best option inside AWS. So it's a proprietary service provided by AWS. They found this, they built this service, but it comes with a lot of nice features as well. For example, it also has options to replicate data across different clusters, and you can encrypt the data, backup and restore. Like general things you expect in a normal database are provided here. And it also provides the advantage of the things you generally expect in a NoSQL database. So a lot of massive customers like Lyft, Airbnb, Samsung, Toyota, Capital One, Redfin, they all use DynamoDB. So for their mission critical workloads, because it's one thing it's good at is it's highly scalable. So maybe it might not be suitable to store relational data, obviously, but in the scenarios where it's suitable for, it performs very well. So you might not want to use it for everything, but when it's suitable to use, it's the best thing you could go for. So if you look at another image here, that's what it's just a summary where they are just telling like you can store different types of key value data, and it gives these features where you can have encryption at rest, global tables, point in time recovery, where you can go to a different, it'll automatically do backups and you can recover in case something goes wrong. So it has a lot of features that you might expect in a normal database management system. So it's pretty cool, and it also, like Aurora, it directly connects with other services in AWS as well, like Kinesis or CloudTrail. Now, Kinesis is a nice example because it's used for big data applications where data is continuously coming in a stream. So those kind of streaming data can be easily put into DynamoDB and taken out, like let's say for processing or something like that. So because, as I said before, it can handle millions of requests per second. So DynamoDB is really good when it comes to that. So that's what they are showing here as well. One thing I wanted to highlight here is the availability here. They're talking about the another cool thing. You can do the same thing in Aurora as well. But what you can do is you can, if you have databases, if your application is very global and a lot of people are using your database across the world, let's say some customers are there in Sri Lanka and some are there in Norway. So, and if you want to provide consistent performance so that people from Sri Lanka will also get the same data in the same latency, and people from Norway will also get it at the same time. So then you can use this thing called these global tables, where you can sync the database across two different tables in, it's the same table basically, but it's there in two different regions. So that it will be two tables. So it will make sure the data is consistent across these tables, and it'll make sure it's available. So people in Sri Lanka will access something close to them. Let's say it's hosted in India, so then they'll access that. And people in Norway will access something in Frankfurt or something like that, or in Ireland. So that kind of a thing can also be done. And all of this availability guaranteed here along with the replication and everything is automatically done for us. So there's nothing for us to manage there. So it's pretty cool that way. So it's another good example of a serverless service here, because everything here is done for us automatically. We just have to configure at the beginning, okay, I want it like this, I want these global tables, and that's it. And they will take care of that automatically for us. Similarly, the security is also there. You can do encryption. You can, again, wrap it around a VPC, and you can do send the access logs to CloudTrail or CloudWatch as well. They are used for logging basically. So like that, a lot of different other services in AWS is also directly connected to DynamoDB. And yeah, so main thing about DynamoDB is that if you are looking for a NoSQL offering in Amazon that provides a very good key value store, it might not be good in terms of querying, and like if you want to do very complex relational queries kind of thing, then it might not be the choice. But if your main use case is to store a lot of these dynamic data and just instantly retrieve them and do a lot of processing, then DynamoDB is the best option because it's very scalable and allows a lot of throughput. So similarly, there's this thing called Documentdb, which is basically, it's allowing MongoDB to be used in the cloud. It can be used within the AWS cloud. Now, I don't know if you guys are familiar with MongoDB, but MongoDB is somewhat similar to DynamoDB, but it provides a little bit more features where you can properly store documents. It's more of a document database rather than a key value store. So there you can do even more complex. You can do kind of relational queries there as well, because they follow a structure called BSON, not JSON, because they kind of change it a little. So it's more through that they are providing more features. You can even do transactions and all with MongoDB databases. So what this Documentdb does is it's simply allowing us to run MongoDB databases in the cloud, but it's again serverless, so you don't have to manage any of those, spinning up the MongoDB server, setting up the cluster, all those things you don't have to do. Documentdb will do it for us. Right now they're supporting 3.6 and 4 API, but I think in the future they'll support more as well. So if you look at an infographic for that, so Documentdb comes with the same advantages you get from a normal MongoDB database, but the best part about Documentdb is that it's going to do these other things like the availability, scalability, the self-healing, the replication, and encryption will be all done for you automatically. So you don't have to manage any of that. So it's pretty useful that way. There are other things that can do this as well, like MongoDB provides Atlas. Atlas also provides a cloud offering of MongoDB, and actually Atlas has some more features than Documentdb as well. But if you are to go for Documentdb, I would say, again, it's if you want to keep everything within the same Amazon ecosystem, and if you do want to go to a different cloud provider, then Documentdb is obviously the best choice. But it doesn't mean if you go for Atlas, you can't connect it back into Amazon. There are ways to do it. You can have a virtual private network there in Atlas, and you can peer it as well. But as you can see, there's a little bit of a hassle there. But so if you use Documentdb, it's all going to be within the same ecosystem, so you don't have to do extra configurations to access your MongoDB from other services in your Amazon. Let's say if your EC2 or your Lambda function is trying to do something with the database, then it will be easier if it's in the Documentdb. So yeah, I just wanted to mention that because if someone thinks about Atlas versus Documentdb, that's the pros and cons there. And finally, we have Elasticache. Elasticache is a caching service. It's again managed, so it's serverless, where it'll allow you to use these open source caching engines like Redis and Memcache. So you can cache the data before you send it to before you hit the database or any kind of storage. So generally you use caching to reduce the hit on your database, so that immediately your user will also get immediate results, and you will reduce the load in your database as well. So its database will also perform faster. And Redis is actually used quite frequently in that in scenarios where caching is required. So Elasticache is a good option to spin up these Redis servers. And again, it's going to do the management of these servers automatically. So it's serverless, so it's going to do it by itself. And it also provides certain features, like if you want to do role-based control inside Redis, and certain features unique to Redis can also be taken advantage using the Elasticache service as well. You're not losing anything by using Elasticache, is what I'm trying to say. So some of the use cases are is that you want to do real-time transactions, business analytics, session storage, gaming leaderboards. Gaming leaderboards is another one, another use case Redis is very useful for. They kind of asked that in the exams as well, because so Elasticache comes with support for the Redis gaming leaderboard, so you can have in kind of these kind of multiplayer gaming applications, you can have a leaderboard easily maintained using Elasticache and Redis. So the Amazon comes with the support out of the box for that. So if you look at this infographic here, what I wanted to show here was, yeah, here also you can do the primary and secondary replicas as well. And if you compare the Redis versus Memcache, Redis provides more persistence and it's more of a data structure store rather than a flat string structure. So I mean, there are different scenarios where you would go for Redis rather than Memcache, but I just wanted to briefly touch upon that. But yeah, so Elasticache is mainly used for spinning up these kind of Redis or any kind of Redis or Memcached caching services, so that you can use that in front of your database to reduce the load on your database, as well as increase the reading performance for your users. So that's another good example of a serverless service, because it's all maintained for us and we don't have to worry too much. Yeah, so if you talk about choosing the correct database service, if you are going for a normal SQL relational database, then you would go for either RDS or Aurora. And if you want a serverless option, you will go for Aurora serverless. That's a no-brainer. But in a NoSQL situation, now all these last three things I talked about, they're all NoSQL databases, but they provide different types of it. So if you want a key value store or a JSON store, then Dynamodb is a good option. If you want to store key values for caching purposes, then Elasticache is good. And if you want to store documents, documents also kind of look like JSON, but you can store, it's a little bit more structured than JSON. So those kind of things you can store, at least using the Mongodb structure, then you can use the Documentdb from AWS. Now, these last three things, these are all serverless as well. The graph, the Neptune. Okay, I think I made a spelling mistake there. It's Neptune, not Neptune. But Neptune, Amazon Quantum Ledger Database, and TimeStream. All these three things are serverless. I didn't dive quite deep into them, but I wanted to mention them because they're serverless and they're pretty cool. Because so Neptune is a graph database, and graph database is good to capture any kind of if you are building kind of a social media application or kind of a contact tracing application, then you will need a graph database. And Neptune is another proprietary offering by AWS. So it's a good option, and it's also again managed, so it's serverless, so you don't have to worry. Similarly, there's Amazon Quantum Ledger Database. That's a very recent service that they introduced, which basically people familiar with blockchain will kind of understand. But what it does is it's going to maintain kind of a ledger-based database, so you can cryptographically verify the transactions that are happening in the database. It's not technically a blockchain. Blockchain means something like a Ethereum, or like you'll have to spin up that Ethereum or Hyperledger Fabric framework, or like you'll have to spin up that blockchain network, and you'll have to maintain that node if you are to do some sort of a, if you want to require some sort of a ledger, you generally, right? So what this quantum ledger database is doing is it's allowing you to do that, but without having to worry too much about creating your own blockchain network, so it's kind of encapsulating all of that for you. So you can just worry about the business logic rather than how you can store it. It's going to store it in a way so that it can be cryptographically verified. So that concept of blockchain is still there. And finally, Amazon TimeStream is for TimeStream data. That means like if you have any kind of small IoT devices that are providing sensor data that is rapidly coming in to your application, then TimeStream is a good option because it can handle real-time data much better compared to other services. Not that others can't, but TimeStream is more tuned for this kind of a scenario. So it's generally used for IoT devices and data coming from IoT devices to be processed. You can use TimeStream for that. So I mentioned those last three just so that just because they are all serverless and they're kind of new offerings by Amazon that's kind of used for these kind of state-of-the-art technologies, So it's cool to know about them as well. Yeah, so I did a lot of talking now, but what I wanted to convey is there are different storage services and there are different database services in AWS, and within that storage services, S3, EBS, and EFS are commonly used, and S3 is a commonly used serverless offering. And when you look at the databases, Aurora Serverless, Dynamodb, Elasticache, and Documentdb are some of the commonly used serverless databases in AWS. I went through some of the concepts there as well, but the main takeoff here is that all these services are there for it doesn't mean one of them is better than the other, right? They're all there for a particular use case. So it's for us to decide which service to use in a particular use case. And if you decide it correctly, then that service will do, then that particular storage solution will be, will give proper results, Because for an example, I'm just giving a scenario here. It's kind of an exam scenario where instead of using EFS, you could also use S3 to share the data across different EC2 instances. But the problem there is it's not fast enough for those instances to carry out. I did say S3 is fast, but it's still not, you can't access it in real time and do real time kind of under a network file system protocol. And you can't do highly parallel workloads with S3, even though it's very durable and scalable, as I mentioned. So all of them have their pros, but identifying which service is good for which scenario takes a bit of time. So you'll have to do a little bit of research before you use one of these services. Because from what I've told, I just told all the pros, but when you try to decide between them, you'll have to carefully consider what is your scenario and go for that. And when you go for that, you'll have to consider what are the pricing options there, and you have to choose that correctly as well. So then that way you can maximize your performance and how much you pay for that as well. So that's what I wanted to cover theoretically. Now I think I took a lot of time there itself, but I'll go through quickly a demo as well on the main services that I talked about. First, I'll show you a little bit on S3. I hope you guys can see my screen. My screen is visible, right, Ishra?
Yeah, it's visible.
Yeah. Okay. So this is an AWS account that I have. It's my own personal account. But what I'm going to show now is I'll quickly go through S3, EBS, and Aurora Serverless. The other things are also kind of, you'll get an idea once I show these things. But so the first thing is S3. So when you log into your AWS account, you can just search for S3 in the top tab here, and it will show up here. And so I already have some buckets here. These are some personal pet projects and something I use for certain courseworks. Some of my friends are using it as well. But you can create buckets here. So when you create a bucket, so this bucket is where you're going to store the data. It's kind of a logical encapsulation, as I told. But these bucket names has to be globally unique. So you can't have a duplicate name because it's kind of a restriction there. So you kind of have to do and then you can choose a region. I'm going to choose Mumbai because it's closer to me, so the latency will be low. And then you have a whole bunch of options here. Generally, you wouldn't dive too much into it. Maybe sometimes you'll have to remove this block public access if you're trying to do a website hosting. But other times you can just give the bucket name and the region, and you can just create the bucket. So once you create the bucket, it'll take a bit of time. But once it's done, so you can see this pop up here. And if you click view details, it'll go inside that bucket. So it'll be empty. You can start uploading it here itself. So S3 provides, you can either come here and upload it, or you can use their SDKs. They have SDKs for different languages as well, Java, .NET, JavaScript, pretty much everything out there. So you can use those SDKs and programmatically upload files as well. Or if you want to directly upload it here, it's up to you as well. So I can show a small sample here. I can just add a file. Just upload something here. So when you're uploading something, there are a lot of things you can configure here. And if you remember this, this is that storage class I was talking about in this slide here, where you can decide how much you want to pay for it based on how long you decide to store it and access it and stuff. So here itself, they're giving a nice summary of each of these options: standard, intelligent tiering, standard IA, etc. So if I don't choose anything, by default, it'll go for this standard option only. But I can choose for standard IA or Glacier or something. So when I'm uploading itself, it'll put it to that correct tiering so that I'll get charged accordingly. This tiering doesn't mean it's going to go to a different place or something. It's still going to be in the same bucket. It's just that you're going to pay differently based on how frequently you access it. So if I just upload it, it'll go that. And then I have my file uploaded here. So this is just an image file. You can upload any type of file here. And if you look at certain properties, and I'm not going to go through all of them, but the main things here is, now if you want to do a static website hosting, that means if you want to host your React application or Angular application, then generally you would want to turn this static website hosting on. You can enable that, and you can say my index document is index.html. And then you can save that. So what will happen then is it'll give you an endpoint here. So this one, right now I didn't upload anything, so it's going to say forbidden. But if you had uploaded some HTML files here, then you can access that using the S3 URL. I can maybe show you that here in this. Yeah. So this is another old bucket that I had with an Angular application that is hosted using a static website hosting. But I basically did is I did an Angular application, I built it, and I just copied the assets over into the bucket. And then I enable this static hosting. And then it starts showing that application here. So since this is a static website, there's nothing much, it just works fine. But if it is a dynamic website, still you can host the static stuff in S3, and you can do the host the other backend and stuff in different places in AWS, and then you can connect all of them together as well. But that's a whole another session. I don't want to go too deep into it right now. But other things you can do here is you can give permissions to the bucket as well. So right now this bucket has public access. Why? Because I'm hosting a website here, so the public has to be accessed. Public should be able to access the bucket. And there's a thing called this bucket policy and cost configurations that needs to be done, which basically gives permissions. It's just to maintain permission so that you're telling, okay, people from the public can actually get my object and just view it, but they can't really put anything into my bucket. They can just view it. So things like that you can configure. For different scenarios, you can do different configurations like that. So this is just for one scenario where you're doing a static website hosting. If you're doing something like video sharing or content sharing on Netflix kind of thing, then you would upload the videos here. You won't make the bucket public. You will keep it as a private bucket. But then there's this thing called either using CloudFront, or there are other services as well, where you can do you can create these secure cookies, and you can only allow access to certain people to view these videos or content that you're getting uploaded to S3. So you can do complex scenarios like that as well, or simple website hosting, image sharing kind of a thing as well. So it's pretty handy, and it's pretty easy to use. As I told you, creating a bucket and uploading is just 5 minutes work. So it's easy to get started with, and but you can do very complicated stuff with it as well. So that's S3. Then if you look a little bit about EBS, the second thing I talked about here, which is the Elastic Block Store, that is basically the storage that is used by the compute service, which we covered last week, which is called EC2. So the EBS is usually under the same EC2 menu. So you generally have to search for EC2, but then you will see in the side menu here saying Elastic Block Store. So you can go there and check what you can do there. So if you go to the volumes there, you can generally, when you start a EC2 instance, it will start the EBS volume also for you. So you don't generally do that, but you can come here and create a volume as well. And you can choose what kind of an SSD or a HDD you want, how much storage you want, how much throughput you want, where do you want it to be stored. You can do that configuration, and you can create a volume. And then also you can, after creating the volume also, you can attach that to a particular instance that you have already running or you're about to start as well. So you have that kind of flexibility. And on top of that, you can create snapshots, which basically means like backups on a particular point of time. So then if you want to restore that backup later in the future, you can come into these snapshots and restore it, or you can copy these snapshots to a different region in AWS. And let's say you wanted to move your system to a different region. Then you can copy the snapshots over to a different region as well. So that's also possible. And you can encrypt these data while it's in rest or while it's in transit as well. So it's secure. I didn't want to show the EC2 thing again because we showed it in the last session. But basically, when you start an instance, this EBS volume is automatically done. In one of those steps, you will see the EBS volume configuration as well. That's that for EBS. Then Elastic File System is again, which is the third thing I talked about, where it's kind of like EBS, but it's more for, it uses the NFS protocol, and it's for Linux systems where you can share the storage across different instances. So this is a little bit more technical to create, at least, I mean, not create per se, to get it configured, because you have to mount into your Linux instance, like you have to SSH into it, and then you have to mount the storage that you're creating using EFS. So there are some commands for that to work. I mean, you can look up. There are several tutorials online if you want to do that. But eventually, what will happen is you can connect different instances to the same EFS storage, and they can all access the same data. So if one of them uploads the data into that network storage, another instance can see that coming into their storage in real time, and they can access that as well if they want. So you can do that. That's how you create the EFS. Configuring it is a little bit technical, but there is a lot of tutorials online you can follow if you want to get that up and running. So those are the storage services. If you look at the database services, so for Aurora Serverless, the serverless offering, for that also you have to first come into this RDS service. RDS means a relational database service. So all the relational database offerings in AWS is under this RDS console. But things like Aurora and Aurora Serverless can be used, can be configured when you're creating the database actually. So I can show you that. So when you create the database, there'll be a lot of different options. So here, I'm going for the standard create. Easy create will, it's kind of, the wizard will kind of change to make it even easier. But I want to show all the options here. So when you go for standard create, you can choose the different engine. Now, if you go for anything other than Aurora, that means you're choosing that, right? Your MariaDB, MySQL, Microsoft SQL means that you're choosing that like generic distributions of that particular database management system. So then you can choose the particular version you want in that as well. But if you go for Aurora, Aurora is a proprietary from Amazon, right? So they have either MySQL or PostgreSQL. And under that, you can then show the, you can check what kind of version you want under the Aurora MySQL as well. Different things have different versions. So sometimes if you want a specific versions, you might, and if it's not there in Aurora, then you don't have a choice but to go for the other one. But if it's there in Aurora, then it's totally fine. And there's a filter here that you can say show versions that support serverless version 2. If you want to go for a serverless offering, then it's good to tick that and then choose the options that are available there, because only these two things here right now can be used for the serverless mode. I'll show what I mean by that. So you choose that here, and then you can choose either production or dev test. Why they're asking that is, if it's production, then they'll make sure the availability and the performance and all is much better. But it's going to cost a bit more. But if it's dev test, that cost is not there, and it's not very available as well. But it's fine because it's dev test. I'll just keep it like that. You can give a database name here, a master username, a master password. Those things can be configured here. And then this is the other place where you have to take a little notice, because if it's generally, it'll be in this it'll be chosen in this memory optimized thing only. So these are actually your kind of, this is not serverless because you're kind of choosing instance to be started, or like the volume to be started based on these particular configurations. And these if you choose one of these, it's not like they are going to be, they don't have the capacity to automatically scale up and scale down, so they will always, if it's 16 vCPU and 128 GB RAM, that means that's it, it's stuck to that. If you have to if you want to change it, then it's kind of hard, because then you have to do a database migration kind of thing. But then here, if you only chose a serverless option here, then you will get the serverless toggle here as well. So if you choose that, then this thing kind of changes. So then it says serverless version 2. And then here you have to choose that ACU thing, where you just say how much GB I want and how much memory I want. And there's no restrictions here. But it's kind of, this is also not like it's a strict limit. It's just like the beginning limit you're giving it to it. After that, if it needs, it will scale up or scale down. So that's the good thing when you chose the serverless option. Other things can be configured according to your needs. So there's this replica thing that I was telling about, where you can copy the data across different regions. And then there's these advanced network configurations as well, to make sure that your database is inside a private network. Then you can do these kind of configurations as well. But if you keep it default, you might want to enable the public access, so then you can directly connect to the database. But for a production workload, you won't generally do that, because it has to be in a secure network. But yeah, so you can do all of that. You can choose the rest of the things. You can keep default if you just want to do a simple database, and then you can just click create. It'll take a bit of time. So since it's going to spin up the server, even though it's serverless, there is servers in the backend, right? So it's going to take a bit of time, but once it's ready, it'll show here the instance is running, and then you can connect to it. So it'll have a public endpoint. If it's a publicly accessible database, it'll have a URL. So you can copy that and use the username password you gave, and use any kind of workbench, like MySQL workbench or any kind of SQL IDE to connect to it and start using the database. So that's for RDS. Other things are the Documentdb also. I can show that here. So you can just search for Documentdb and you'll see this here. So when you create a Documentdb, it's going to ask what MongoDB version you want. So it's kind of a limitation here because you don't have the latest versions of MongoDB here right now. So that's why I was talking about Atlas also a little, because Atlas provides much more features compared to Documentdb. But if you want to keep everything inside Amazon, and if you don't want to make everything easily compatible, then Documentdb might be a good choice. That's all I wanted to show. Dynamodb. I wanted to show that as well. It's a managed NoSQL database. So the Dynamodb is the, as I said, the proprietary offering by Amazon. It's very scalable and it's very throughput optimized. So Dynamodb works under the concepts of tables. So you can create different tables and you don't have to provide. So these tables aren't tables that you create in SQL where you have to first provide what kind of columns you want and things like that. You just have to give a table name and you can create it. But there are these concepts called partition key and sort key. Those things are used for indexing and to make it more faster to query the data, right? But you can dive more deep into it. There are different tutorials you can follow. But yeah, Dynamodb uses the concept of tables, but it's not the same as normal SQL tables. You will be storing data as key value pairs and like JSON documents, and you can retrieve it and write very fast to it, and it's very scalable. So that's about it. So the final thing I just want to show is I just want to talk about some of the things I used here for these slides. I'm hoping it'll be useful for you guys as well if you're trying to learn anything new in AWS or if you're trying to do a certification. These are just some of the resources you can use. So the first thing is this architecture website where you can, I think this is the one. So you can go here and you can find different white papers, reference architectures, guidance, videos. So it's really useful if you're trying to learn something new in AWS, not just serverless or anything. It can be anything because for pretty much all the things they're offering, they have kind of a tutorial here. And the other thing is if you're trying to build something complex, some kind of an architecture, almost all the time, someone else also might have done it previously and they might have some best practices to follow. So if you use this reference architecture, then you can easily find what is the recommended approach that AWS is telling, AWS is recommending. So then you can follow that to create your own system. The other thing is this, it's also a white paper that's under this architecture website, but this is an overview of all the AWS services. If you're very new to AWS, I would suggest going over this link. This will go through the entire AWS service and all the different offerings they are giving. It's a very high level overview, but it'll give you a nice idea of what they are giving, what they're offering. And finally, it's this awsgeek.com where from there only I took all of these images, those nice infographics. And this is very useful if you're trying to do a certification, because when you're trying to learn a particular service, you might tend to forget certain stuff. So these infographics will immediately give you a quick refresh of a particular service or everything you need to know, right? So this is also a pretty useful website. I use that for the slides as well. So yeah, that's about it. Sorry I took so much time, but I usually do that. But I hope the session was useful and you guys learned something. And if there's anything, you can always reach out to me. I'll try my best to reply, and you can reach out to 99x as well. So we are happy to help anything AWS related. So yeah, that's it from me. Thank you, guys.
Yeah, so that was a very detailed and very knowledgeable session on AWS data services and databases as well. So yeah, we can go ahead and start the Q&A session now. So if you guys have any questions, you all can drop it on the chat or even unmute yourselves and ask.
It's, I mean, like if you guys even have anything, any other doubts, you can always reach out to me offline or just drop me a chat. I'll try my best to reply. I knew I was going overboard, but I just wanted to cover as much as I can because it's an interesting topic and I didn't want certain things I actually didn't need to talk about, like these FSX and all, but I just wanted to drop them there so it's complete, so everyone gets an idea of what's there. So yeah.
So the infographics might help a lot of people out.
Yeah, this is a very useful website. I'll drop it in the chat as well. If anyone is talking about some service that you don't know, you can just come here and quickly, if that service is here, it'll be really easy for you to understand what's happening there. Yeah.
So looks like no one has any questions, but if you all do, and if you want to clear it out later on, you all can always reach out to Keshav through his email or reach out to the 99x at any time. So I think we are good to wrap things up.
Yeah.
So yeah, I think now I'd like to take the time to thank Keshav for accepting our invitation and taking a bit of a very busy schedule to like share his knowledge with all of us. So a very big thank you to you. And our next webinar on this series will be happening in a couple of weeks' time, and it will be regarding the application integration services. And hoping that all of you will join there as well. And also one more thing, don't forget to keep in touch with our social media platforms for like all the registration links regarding the upcoming sessions. And if you want to refer to any of the recordings of the previous session or even this session, you all can go visit the YouTube channel, the 99x YouTube channel, and check out for the playlist over there as well.
Okay then.
Yeah.
Thank you guys. Thank you for joining.
Thank you
Thank
for
you.
joining.
Thank you for staying until the very end. So hope to see you guys again in another session. Thank you guys.
Bye bye. Have a nice day.
Have a nice day. See you.